Problem 4.6.9. You are given two differential equations with initial conditions. Solve the systems of equations by Laplace transform. Okay. So the first equation, we have s squared x of s minus s x of 0 minus x prime of 0. And then we have a second order for y this time, plus s squared y of s minus sy of 0 minus y prime of 0. And then t squared, we have Laplace transform of t to the power of n equals n factorial over s n plus 1. T squared is going to be 2 factorial over s cubed. And let's put the initial condition x prime of 0 is 0 and y prime of 0 is 0, y of 0 is 0, x of 0 is 8. So we have collected x of s terms together. S squared, that's the only one. X of s minus 8s plus s squared y of s equals 2 over s cubed. And then second equation, we have x squared term. So s squared x of s minus s x of 0 minus x prime of 0 minus this time y squared term, s squared y of s minus sy of 0 minus y of 0 equals 4t, which is 4 over s squared. Now put the initial conditions. X prime of 0 is 0, y of 0 0, y prime of 0 0. This is the 8. Now we have s squared x of s minus 8s minus s squared y of s equals 4 over s squared. So let's put those equations in terms of x and y. So the first equation, we have s squared x of s plus s squared y of s equals 2 over s cubed, move it over, plus 8s. So combining these two, so we're going to have a common denominator s cubed at the denominator, and then 2 plus 8s times s to the 4th. Okay, the second equation then, s squared x of s minus s squared y of s equals 4 over s squared plus 8s. So let's combine these two terms. Then we have s squared as a common denominator. Numerator is going to be 4 plus ss cubed. So now we can find delta 1 and delta 2. So for delta equals coefficient of x and y's, s squared, negative s squared. That equals AD negative s4 minus BC s4, that is negative 2s4. And delta 1, so the first column is going to be these two, so 2 plus 8s4 over s3, and then 4 plus 8s3 over s2, and then second column is going to be s squared negative s squared, AD negative s squared times 2 plus 8s4 over s cubed minus BC. We have s squared and then 4 plus 8s cubed over s squared. Let's simplify a little bit. So the first one, s squared, and then square is going to go away. And then we have s as a denominator, and we have a negative. So negative 2 minus 8s4, and then minus. So for the second term, let's keep one s at the denominator, okay, so that we can combine the first and second term. Then we need to multiply s. So basically s, 1s over 1s, okay, cancel out. And then s times 4, 4s plus 8s to the power of 4. This way we can combine these two. So the common denominator is going to be just s, and then negative 2 minus 8s4 minus 4s minus 8s4. That is negative 16s4 minus 4s minus 2 over s. Now let's do delta 2. The first column is s squared and s squared. 2 plus 8s4 over s cubed, and s squared. 4 plus 8s cubed over s squared, and that is AD. S squared 4 minus 8, 4 plus 8s cubed over s squared, minus BC, s squared 2 plus 8s4 over s cubed, and that equals, again, the second term, we're going to have one s at the denominator. So the first term, we're going to keep s, then 4s plus 8s to the power of 4 minus, denominator is going to be just s, 2 plus 8s4 combining together. Common denominator is a s. We have 4s plus 8s to the power of 4 minus 2 minus 8s to the power of 4. That is now 4s minus 2 over s. Now we can find x of s, that is delta 1 over delta, and delta 1, we have negative 16 s to the power of 4 minus 4s minus 2 over s. And then delta, we had negative 2 s4, 1 over negative 2 s4. And then we can combine these two. Then we have negative 2 s to the power of 5. And the numerator, negative 16 s4 minus 4s minus 2. And if we separate these three terms, then we have negative 16 over 2, which is 8 over s for the first one. And then minus minus to plus 4 over 2. So 2 over s4, and then minus minus plus 1 over s5. That is x of s. And then y of s equals to delta 2 over delta. And delta 2, we have 4s minus 2 over s. And delta is negative 1 over negative 2 s to the power of 4. Now we have a numerator 4s minus 2, and the denominator is going to be negative 2s5. Again, let's separate this. Then we have y of s equals, this time negative 2 over s4, and then plus 1 over s5. So now we can take the inverse Laplace transform of this. We have 1 over s4 and 1 over s5. Now in the pair, we have Laplace transform of t to the n equals to n factorial over s to the n plus 1. Now for t to the power of 4 equals 4 factorial over s to the power of 5. So we have to have 4 factorial in the numerator. So based on this relationship, it's going to be handy to have one formula It's a kind of inverse Laplace transform of 1 over s to the power of n. That is, we need to multiply n minus 1 factorial, just like this, and then t is gonna be n minus 1. We are looking at this relationship, the power. So we have s5, so 1 over n minus 1 factorial, and then the t to the power has to be 1 less than s of the power. So if you have this on your cheat sheet, it's gonna be handy. X sub t now, x sub t equals 1 over s. It's just 1, so we have 8 plus 2 over 3 factorial t to the power of 3. We're just using this formula, and then 1 over s5 plus 1 over 4 factorial and t to the power of 4. For y of t equals, we have a negative 2 times 1 over s4, therefore 1 over 3 factorial t to the power of 4 minus 1, which is 3, plus 1 over s5, again 1 over 4 factorial t to the power of 4. So this is the answer.